Welcome to Brain Vision.
So we want to find the minimum energy required to remove a proton from the nucleus of a carbon-12 atom. And the following is the difference between the mass of a carbon-12 nucleus and the mass of a proton plus the mass of the nucleus formed from the removal of the carbon-12 atom. So looking at our periodic table, we know that if we remove a single proton from carbon, we must be left with boron, which has an atomic mass of 11 and carries 5 protons. So now, to calculate the energy required to remove this proton, we want to calculate the mass difference of the nuclei of each of these atoms, which is given by the mass of carbon-12 minus 6 times the mass of the electron. So this is just subtracting off the electrons from the mass of the total atom. And now we want to subtract from this the mass of the boron nucleus, which is the mass of the boron-11 atom, minus 5 times the mass of an electron. And the energy, of course, is proportional to the difference in mass by c squared. If we calculate this value, we find that it is equal to 15.92 mega electron volts. Now, we want to compare this value to the binding energy per nucleon for carbon-12. So this, of course, we can calculate, again, from the mass difference of the constituents in the carbon, or the difference between the constituents of the masses of carbon and the mass of the total carbon atom itself. So this is, of course, 6 times the mass of the proton, so there's 6 protons, plus 6 times the mass of the neutron, because there's 6 neutrons, minus the mass of the total carbon atom. And of course, we again multiply this by c squared, the proportionality constant between the difference of mass and the energy. And we find that this gives us, of course, and we want to find the energy per nucleon, which for carbon is 12. So this gives us a value of 7.42 mega electron volts per nucleon. So those are our final answers.